All right, so this is my demo environment. I have a controller running on-prem. I have some workloads running on-prem, some workloads running in AWS, some running in Azure, okay? And so let me switch my screen. So this is my dashboard. This is when I log in. I'm logged in as Ashish as a user. I'm in the demo tenant, as you can see on the right-hand side. And the first question you should ask is, where are my load balancers? These are not load balancers, these are applications. Each box represents an app. And why you should ask? Well, why do you deploy load balancers? For applications, security, availability, and performance. What you care about is apps, not load balancers, right? Load balancers or managing the infrastructure is controller's job. Your job as a user is applications. That's the default view. As a user, I have some apps running on-prem. Some are running in AWS. Some are running in Azure. I have a single view across all clouds. And if you want, I can zoom in further. I have single view across all clouds of my apps. Point one. Point two, the color. What does the color represent in a score? Well, it represents the health of the application. Let me go deeper. So if I say this one, this application, it's a demo application, has a health score of 33. It consists of 4 things. Performance of the app. That itself has multiple components. It measures throughput, it measures errors, latency, anything at the performance HTTP level. The score is 66, which is okay, not bad, but not excellent either. And we can double click into what those components are. The second score is the resource penalty, and this is an interesting one. It measures the resource utilization of 2 components, load balancers, as well as backend applications. Because either of them could be a bottleneck. And you can create triggers on these saying, if my application CPU goes above this, auto-scale applications. If my load balancer CPU or memory or latency or connections, whatever they may be, scale out load balancers. Okay, that's the resource utilization. Anomaly penalty measures any anomalous behavior, unexpected spikes or drops. And a security penalty is a measure of, well, any attack that might be going on, DOS attack, WAF attack, or what if a TLS certificate is about to expire? Or what if I've configured a weak cipher? All of that get composed into a single score. And you can double click on each of these. Yeah. And this, by the way, across anywhere, right? On-prem or cloud. Let me show you a slightly different view. Same application. I show tree view. This is the first time you see load balancers or service engines. Active, 2 of them. Health score of 100. They're healthy. Okay? At the top, this virtual service or virtual server has 3 pools of servers. So /contactors goes to a set of 2 servers, /downloads goes to another set of 2 servers, everything else goes to this set of 4 servers. This screen is showing you application-centric view of the underlying infrastructure and their health. So this is fine. This pool has 1 server that's grayed out. It's disabled by the user. This one has it red. Why? Oh, connection is refused, so health monitor is failing. So VM is up, but looks like the web service is failing. You don't have to install any agents. You don't have to do anything. Just right out of the box. How's my application doing, and what are the corresponding constituent parts, and what are their healths? Okay. Now, I'm going to do 2 parts of demo. So this is just an overview. Two types of demos. One, day 1 provisioning, where I've installed Avi and I want to configure a new VIP. Like, as an admin, you want to configure a new virtual server or virtual service. What does that experience look like? Let's start there. And then a day 2, where how do I troubleshoot any performance issue? Okay, let's go. So let's create a virtual service. I'm going to start with a basic setup. That just means that most of the common parameters are templatized. And I'll go into some of the advanced settings as well. So this I'm doing as a user. Okay, I'm doing self-service. Most of the customers do self-service. I mean, today, traditionally, with hardware load balancers, it's a ticket-driven operation. I want a VIP, open up a ticket, a few days later, VIP is created. Well, let's change the paradigm. Let's have a cloud-native experience. Customers in public cloud don't open up a ticket. They call an API to create an ELB. Let's do that. This UI is using APIs under the hood. So while it's easy to show demo with the UI, identical, it's actually calling APIs under the hood. Okay? And I'll show you that in a minute as well. All right, so I said create a web virtual service. The first question is where? On-prem, AWS, Azure, where? Well, how does it know? Great question. So I skipped phase 0, which is on phase 0, on day 0, I've configured the different environments I want to run in. So I've configured some on-prem VMware environment, some AWS, some Azure, and if I click on this, it tells you what I have configured. I've configured credentials to vCenter in NSX if you had it, and I've configured a few other things there. In AWS, I've configured access credentials, the region, and I've configured VPC information and availability zone information. Same thing in Azure, same thing in anywhere else. This is day 0 config. Okay? This is how the controller is able to talk to each of the infrastructure components to be able to spin up a VM, plumb the network, and so on. Okay? So that was the day 0 configuration. So that's how this screen knows where I want to spin it up. So let's do on-prem first. All right. So let's give it a name. I'm going to call it Avi NFD app. Oh, I need to be clicking on the box. Avi NFD app. It's just a name, nothing else. I want SSL TLS. Okay, configure TLS. I can configure my own cert. I can pick up one of them that's already installed. How many know the difference between RSA certificates versus ECC, elliptic curve certificates, right? Which is better?
ECC.
Thank you. What do most customers use?
RSA.
Okay, excellent. Why is that the case?
Because it's faster, cheaper.
It's potentially cheaper. It's actually not faster. It's slower.
Faster, yeah.
It's the default behavior. And most people are worried about, well, if I change it, what happens to my compatibility? Well, we solve the problem. On the same VIP, you can configure both EC and RSA and make EC first. So by default, you'll negotiate EC. All 99.9% of the browsers support EC. Some devices might not. They support RSA. Then back up with RSA. So no compatibility issue, better performance, better security. We solve a user problem, right? All right, done. Then, what are the common operations that a user has to do when they configure a VIP? Well, you need an IP address. Well, where should I get an IP address? How do I get it from an IPAM? I need to publish that into DNS. I need to find out the pool members. I need to decide where to place a VIP, which load balancer has a capacity, and to plumb it in the right network with the VLAN. These are the manual steps today that you go through. Okay? Well, the first thing is auto-allocate a VIP. I don't care what IP address, just auto-allocate it. Okay? All I care about is just put it on this subnet. And that also can be potentially eliminated. And the last thing is, I've configured some DNS. You can third-party integrations with Infoblocks. We have our own IPAM and DNS. Publish the FQDN as well. Just don't bother me. Just do it automatically. Okay? That's the front end of the app. Let's actually add the backend servers. Now, I could type in IP addresses, but that's manual. I'm lazy. I don't know what my IP addresses are. So I say, well, show me what you've got. So my controller is doing discovery through vCenter, getting a list of all the networks. If you're in AWS, it'll get a list of all the networks in AWS as well. I know my app is running in VLAN 100, and I need to add, and it sees a list of all the VMs, and I want to add these 3 VMs, servers, and save. I'm done. Behind the back, it called one macro APIs with all the policy, saying auto-allocate a VIP, these are the members, just go do it. Well, what did the controller do in the backend? What controller did was, it first said, okay, let me take the capacity assessment. Which service engines have capacity? If they don't have capacity, it'll go to vCenter to spin up a VM. Once a VM is spun up, it says, okay, let me auto-allocate an IP address from IPAM. Let me plumb the network with the VIP network and the backend network. Let me download the policy. Let me publish the name to DNS. All of that was done in a few seconds. In this case, it did not have to spin up a new VM. That's why it was instantaneous. If it did have to spin up a VM, and I'll show you that as well, it might take 30 seconds because it talks to vCenter, VM comes up, once it connects and plumbs it, right? That's self-service. That's automation. Automation just doesn't mean API. Automation means decision automation, okay? Where this is what I want to do. Just figure out and do it. Don't ask me to manually do API call for everything, right? That's the difference. Now, this is where our customers use this in on-prem and cloud. Sometimes the developers don't even know whether the API call is going to on-prem or cloud when they're using Avi, because it's the same API. That's different. All right. So far, we've just looked at a simple VIP creation. You might ask, well, you didn't pick up a load balancing algorithm. You didn't set up persistence. You didn't do all of that. Fair enough. That was because it was all templated, defaulted. But you could. So you go here and say, OK, let me configure its pick least connections. I can change it to round robin. I can change it to hash, fastest response, whatever the case may be. It auto-created health monitors. I can add more health monitors. I can set up persistence, whatever the case may be. All bells and whistles are available. Because most of our customers have moved from legacy hardware load balancers to Avi, so we have to support the same features. So that's not an issue. Another common question is, what about advanced ruling capability? Can I say, if this matches, do this? Yes, you don't have to write any complex scripting or anything. It's native. So for example, I can say, add a match on, well, you pick, let's say on a path, and do a regex, or say ends with a certain string. Then I want to allow, deny, rate limit, redirect, anything. All possible combinations are available. So it's a very rich feature set. That's the idea. It's not a basic load balance. It's an enterprise-grade solution. All right, so that was day one. I configured a VIC. My traffic is running, and I don't have traffic generator on this one. So I'm going to switch to a different one where some traffic is running. And I'm going to do day two troubleshooting. All right? Let me go back here and go to this one. This is the one we saw earlier. Let me double-click into that one. Aha. What do I have here? Looks like a nice, pretty graph. Let's see what it says. It says end-to-end timing. What does that mean? This says over the last 6 hours, or last day, or last week, last month, pick your time window, what is the latency as experienced by my end user of the app? The average is 137 millisecond. Because at the end of the day, who defines the application is running fine or not? Not admin, it's the user. If their bank transaction is failing, even if your all charts are green, you have a problem. So this is the default screen, not throughput, not connections, which are also available, by the way. This is the default screen. And what this says is that latency breakdown is 83 milliseconds on the WAN, 2 milliseconds on my local network. My application is averaging 42 milliseconds. And on the wire, between the first and the last byte, it's 10 milliseconds. Breakdown. No agents, out of the box. That's average, though. You see some of these spikes here. There's one's coming up right now. Who gets blamed for performance issues?
The network.
Always. Does it have to be? No, it's guilty until proven innocent, right? This is your mean time to innocence tool. That's one of the customers coined that word, MTTI, mean time to innocence. Why? Because here this tells you that this application spike, latency spike, is app latency, 71 milliseconds. Everything else is fine. Application latency should be in the 30 millisecond range. It's 70 milliseconds. So it's not the network, it's the app.
Ashish, you said you're doing this without agents.
Yes.
Do you guys have monitoring setups in the cloud that's constantly coming back?
No, we are a full proxy. So we can't tell you where in the cloud, where in the WAN there is an issue. We can just tell you, is it a WAN issue or a local network issue or an app issue? Because we are a full proxy. We terminate TCP and HTTP. And we have some intelligence to be able to distinguish between that. Okay. Yep. So think of this as the first troubleshooting thing. And if it's supposed to be WAN, then you can go after a service provider or a different tool that where in the WAN there's an issue. If it's with the network, you can look at NSX or Verni and so on, that which switch or which VM might be an issue. But this is a top level view. But in this case, it's an app. We can actually tell you more than this. So let's go to the next screen. And I click on logs. We're a full log analytics system. Every application transaction log is captured. Okay? By default, we propagate what we call significant logs. Logs that we have identified to be an error. So let's open one of them. Let's open this one. Oh, no, I didn't want to do that. I just wanted to open this up. Okay, so this log, and let me zoom out a little. This transaction came from this IP address, coming from Nigeria, on somebody running on a Chrome browser on a Mac OS with this TLS profile. This transaction took 21 milliseconds to hit the load balancer, 1 millisecond to the server. Server number 3 responded. HTTP get 1.1 request for this file, and all was fine. The problem is high app response time. So we decided, the system decided, that I have baselined the application latency, and 202 millisecond is out of the bounds. So it called it out. Otherwise, there is no issue. It's a 200 response, right? So let's double click into that and say, okay, show me all transactions that have higher than 202 millisecond latency. So I just click on that Google-like filter. Aha. You see my spike earlier in the other screen? Right here. So I've nailed down the application latency issue. Now I can do more, okay? Is this tied to any specific access pattern? No, it's across multiple URLs. Maybe it's tied to one of the backend servers. Yep, almost all is just one server. So not only I can tell you it's not the network, it's the app, I can tell you it's this server. And go to my server team and say, fix something there. There's something going on there. That's intelligence. Now, I could also, this is troubleshooting. I could also do the other way. If I'm an app owner, I want to know who's accessing my application, which browsers are accessing my application, which devices am I accessing my application. Why is this important? As I do my A/B testing of my app, I need to know what do I test against. I can measure, I can actually quantify, is my new version of the app better than the older one? And we have built-in knobs to be able to say, if the new version is better, send all the traffic to the new version, otherwise fall back. So we can do Canary upgrades, we can do blue-green testing, we can do all of that with this. All right, let me show you the last part of the demo, which is on the WAF. But before I do that, any questions here? Okay. It's more than a load balancer.
I had one question. It was back in the beginning of your slide deck. I won't make you go back there. But when you were showing the health of the various devices, there's a numerical value there. And I feel like that number is sort of arbitrary. How are you determining that number?
Great question. So let me actually show you.
There are many devices out there, right, that say, like, your security report is 7 for the day.
Right.
I'm
so
giving you those data points. So I'm just kind of want to know, how do you determine those data points for that health value?
Correct. So the let me actually go into the same one. There is a security. So let's say the security score, right? So every component has a certain score, and I can actually go into health as well in a minute. But the security screen, once the data catches up, it measures the SSL profile, the TLS profile, the SSL score itself. Here it's dinged because there is a self-signed certificate. So some of this is coming from here, right? So for example, if it's about to expire, then this score will start going lower. So part of the score is coming from here. Now, if I go to the health screen, this is where you can see the larger view saying my 33 is primarily because the performance is lower and so on, right? Now, right, the performance score is 66, the resource penalty is 13, security penalty is 20. If I click on the performance score, then it then further breaks it down and says this is because this pool performance score, so the pools are not performing as well. So you can keep drilling down. So everything gets normalized to 100, and then we give various weights and these are customizable. So for example, some customer says, you are classifying this latency to be out of the ordinary, but I know it's okay. You can change the sensitivity saying, increase the acceptable range. So something is learned, but you can override that.
Great, that was going to be my next question.
Yes. Okay, right. All right, so by the way, what I did just now on-prem, exactly the same thing in AWS or Azure, full automation. Now let's talk about WAF. And as I said earlier, right, one of the biggest issue with WAF is just lack of visibility, okay? So in addition to showing the logs that we saw earlier, if I'm running my WAF in blocking mode, so you know the concept of detection mode where you just identify the issues but don't block the traffic, you can also run in that or in blocking mode. So here I'm running in blocking mode, and the log actually tells me a few things. It tells me, first of all, what was the processing time at each location, right? So the request header took 0.16 milliseconds, body took 0.533 millisecond. It never ran to the response because the traffic was dropped. It was dropped because it matched a rule that said OS file access attempt. Okay, so this is the level of visibility that you get, saying something was dropped. Why was it dropped? Because this was a file access attempt. Now this is individual logs. You could also go to the WAF analytics screen, and it tells you what are the common profiles, what are the common groups within the CRS rule set that are getting hit, SQL injection and file access. What are the common, that's a group, what are the common rules that are getting hit? What are the common patterns of IP address and the paths and so on? So much more visibility into what's going on. And the last thing I want to show you, before going back to the slides, is, well, we talked about horizontally scaling architecture, right? And so for the demo purpose, I don't have auto scaling because auto scaling is enabled. You won't see, there's no fun in the demo. It would have scaled out automatically. Instead, let me turn on, do that scaling through by hand. So here, this virtual service is running on 2 load balancers active, okay? And I can say scale out. Oops. So this is an API call that's going in. And what it's going to do is, it says, okay, processing the request, retrieving and comparing host resources to determine the optimal placement. This is decision automation. It's deciding, I want to scale out. I have a cluster of hosts in my environment. Where should I spin up a new VM, right? Because it's making sure it's anti-affinity. It's making sure that that host has enough resources. It's making those decisions. It's decided it is host 128.18. It's waiting for that VM to be created. So it's called vCenter, spun up a VM. And it'll take a few seconds, and we'll come back here and then see that within a few seconds, this would have been changed from 2 down to 2 up to 3. That's what we talk about when you talk about horizontal scaling and automation. Okay, so we'll come back in a couple of minutes here and check this out again. The other common question I get asked is, well, what about role-based access control and all that? Yes, it's a full multi-tenant system, multiple tenants, and very fine-grained role-based access. So you can say, you can do a full access, read-only access, or no access at individual objects level. Can I create a VIP? Can I install SSL certificate? Can I change WAF policy? Or am I read-only? Right? Very, very fine-grained access control. The last thing I want to show you is, you saw a lot of metrics. Well, one is for show, but can you make anything actionable? Can you take an action based on some of these metrics? The answer is yes. So that goes to my operations tab, and I say, I want to create a new alert. The alert could be based on any system event, like something came up or went down, or it could be a metric on an application. Say for this application, if my application latency, let's say the client application response time, goes above a certain threshold, then take an action. And the action could be send an email, okay, syslog, find, trap, run a script. The controller is a Linux machine. You can run any script on saying that if this happens, the script can then plug into your ticketing infrastructure to open up a troubleshooting ticket, or it can log in, create a VRA template to auto scale your applications, or change the GSLB weight to burst into cloud. You can do lots of interesting things with these metrics. It's a very, very powerful engine from that point of view as well. All right, what you saw here is a single solution that works on-prem, public cloud, containers. And we didn't have a chance to go through all the demos, but we can share those with you. We have some public references from our customers, like Adobe. It's a public reference that said, we were instrumental in getting them to move to public cloud. They're using us on-prem in a bare metal environment, and they're using us in Azure. And they're using multi-way ECMP. Okay? We have Deutsche Bank running us in their container environment, again, on-prem and in cloud, providing ingress services. Yes, same bits. And then, in addition to seeing all the benefits, we also save money. On an average, our TCO savings are about 50%, or 20 to 30% on the CapEx and the rest on the operation savings. So it's not just better features, better architecture, but also cost savings. That's all from me. We can take more questions if you want.
On the central management,
yes.
Does that apply both across container and bare metal that you're running in premises?
Yes. So from a same controller, you can run bare metal workloads, container workloads, VM workloads. Typically, you deploy one controller. It's a cluster of 3 within a region. So our latencies are typically 40 to 50 milliseconds between the controller and the service engine. So if you're a multi-region customer, they typically say one set of controllers for West Coast, one for East Coast, one for Europe, and so on.
I was thinking more have bare metal, you're running on bare metal at the edge for your WAF functionality, then do the actual load balancing closer to the hypervisor.
Question. So in terms of the packet flow, so that's a good question. So by the way, we don't have to run on edge in terms of NSX. Most customers actually prefer to use this in the compute infrastructure because then we're not limited by the compute nodes, right? You can do scale out active. So you don't have to run on edge. In terms of, let's say, 3-tier architecture, you deploy WAF in DMZ and then the load balancer from the application. That's one way to do that. So we have a couple of customers who say, I want to have a separate WAF tier in the DMZ and then the separate applications in front of the applications. A more optimized deployment is combine the two because we have a unified pipeline. As the traffic comes in, right, you do TCP termination, you apply layer 3, layer 4 rules. So let me show you this stack actually. The traffic comes in, you apply layer 3, layer 4 rules, terminate SSL TLS, terminate HTTP, apply layer 7 rules, then apply WAF rules, re-encrypt, and go. So one pipeline, do everything. That's also possible.
So there's no concern with overwhelming the hypervisor that's running your web server and your database server if you get hit with malicious traffic?
So this is not running in the hypervisor. This is running as a VM, right? And the indirect question you're asking is what's the performance of these service engines, right? So these service engines can be as small as 1 core or as big as a 2-socket bare metal server or anything in between. And the performance scales linearly. 1 core gets you about 1 gig of crypto throughput, bulk SSL throughput, but 4 to 5 gig of layer 7 throughput. But 2,500 SSL handshakes per second, new handshakes per core. 2 cores, 2x, 5 core is 5x. So performance scales linearly. So no, there is no impact of running both WAF and load balancing on the same VM. No, you size it appropriately. And by the way, we run active-active. That's one of the other key components. We don't run active standby. You could, but why would you? I think running active standby is a criminal waste of capacity. I'll say it out there. You should not be running active standby anything. You should be only running active-active. That's a modern architecture.
So do you see that as any potential limitation kind of in a distributed NSX model where eventually I would hope that instead of having to have, today kind of the VNF model where I've got a load balancer deployed on maybe a couple of hosts or a services cluster or something, I want that functionality to distribute out just like I get with NSX. Because of that scaling, because the load would not necessarily be the same depending on where hosts are, do you see that there might be
so actually, I understand your question, but we are by definition distributed. The difference is that you don't need to run on every host. At least a layer 7 TLS level. I'll tell you why, okay? Because when you're doing active-active, we actually share the SSL TLS state, right? So if a client comes in, as you know, a browser typically opens 5 or 6 TCP connections simultaneously, but it should do only one TCP SSL handshake. So we have to share the SSL TLS state. So we're able to do that today across different service engines, VMs. And we're able to scale based on performance. At some point, will we look at doing it in hypervisor? Maybe. But at this point, we can do BGP RHI, so we can do ECMP that way. We recommend layer 3 load balancing in terms of sending the traffic. So no, we haven't hit any performance issues that way. Is there more time for more questions, or we're done? Okay.
I have
anything else?
I have,
Yes. Yeah. Go ahead.
Just one small one. Architecturally, do you guys have a way to do non-terminating load balancing? For example, I think the design is called like a stateful load balancer or firewall load balancing. If you have multiple firewalls you need to go across.
Yeah, so there are a couple of things you can do it. When you say it's stateful versus stateless, you're talking about either fast pass or non-proxy, basically not doing a full proxy.
Non-proxy, right? It passes it through to the
yes.
side.
So we do DSR today. Direct server return is an option. We don't have to do SNAT. So yes, it can do non-proxy as well. And what you're referring to is firewall load balancing.
Yep.
Basically, the wildcard virtual VIP.
Yep.
Right. Yeah, that's coming in the next release.
The next release due out?
3 months.
Okay. Thank you.